Alright, so let's take a look at something else we can do with interpretations. We can prove that two sentences are not equivalent. Okay, so a lot of the time we can only prove negative results. Like you saw before, we can show that a sentence is not quantificationally true, but we can't show that it's quantificationally true. We need to do a derivation to do that. We can show that a sentence isn't quantificationally false, but we can't show that it definitely is quantificationally false. We can't prove like a positive result. We have to use a derivation to do that. The reason that we can show sentences to be indeterminate is because that's just showing that they're not quantificationally true and not quantificationally false, which we can do. And it's kind of the same thing with equivalence. To actually show that two sentences are equivalent requires a proof using a derivation system. But what we can do is show them to be not quantificationally equivalent by building an interpretation that makes them, that gives them different truth values that would make one of them true and one of them false. That'll establish that they're definitely not equivalent. Okay. If you think that there are equivalent, you would need a derivation in order to prove that, and we'll see how to do that tomorrow. But let's take a look at this pair of sentences. Okay, there is something that's F and G, and not everything is not F or G. Okay, so something like this is a little bit hard to reason about, but it says there is something that is not F or G. So this one I think we can just go right into without trying to interpret this in English, and there's a couple reasons for that. But one of them is this is really not. This is kind of a convoluted statement that you don't really see in English, so it would be a little bit make it more trouble than it's worth to try to give this some kind of interpretation in English. It's not really going to help us out much in this case. But let's go ahead and show the extensions of our predicates. F and G. So we want something that's going to make one of these true and the other one false. Okay, if we can do that, then we're done. We've shown them not to be quantificationally equivalent. Okay, so this says that there's something that's F and G. It's easy to make that false. We just don't put anything in this intersection here. Okay, and this says not everything is not F or G. So think about what this says. It says it's not F or G. That means that it's not. That means that X is not. It's not in these circles. Okay. So this is saying not everything. This does not describe everything, or this is not true of everything. So that's easy enough. Let's just put something here. Albert is F. Okay. And this is false. There's nothing that's F and G. And now this is true. Not everything is not F or G if something is F. So these are not quantificationally equivalent. Let's go ahead and give the formal description of our the formal description of our interpretation that we've sketched here. Our universe of discourse is Albert. The extension of F is just this ordered tuple with just Albert in it. And the extension of G is null. Okay, so this is false. There's nothing that's in both of these. There's nothing that's F and G. And this is true. Not everything is not F or G. Something is F, right? And if it's F or G. So true, false, not equivalent.